Hi guys, let's take a few minutes and talk about how to find the sample size in order to establish a particular margin of error when we're building a confidence interval for a population proportion from sample data. So we start with our sample proportion and we add and subtract Z star, that is the critical value that tells me how many standard deviations above and below the sample statistic we need to subtract and add in order to build the boundaries for our confidence interval. So this particular number of standard deviations, this is the margin of error. So notice in the data that we used recently, which involved 30 randomly selected freshmen and sophomores from our school, 22 of the 30 purposely conformed and reported an obviously incorrect answer based on the pressure of the situation that they were put into. And the margin of error that we established for that set of data was actually pretty extreme. So the margin of error in that situation was 1.96 times the standard deviation, and the standard deviation was 0.08. So understand this margin of error was plus and minus 0.1568. The margin of error was nearly 16%. That's pretty large. So what would we have to do to this study to improve our margin of error? Let's say cut it in half. What would we have to do to accomplish a margin of error of, let's say, 8%? Well, one of the ways to do this is to take the formula for the margin of error. Here is the expression for the margin of error. So let's take that, and I'm going to abbreviate margin of error as MOE for margin of error. The margin of error is our specific critical value times the standard deviation. In this case, I'm going to include P and 1 minus P over N. So I'm not going to use P hat in this case because in this situation, what we're going to have to do is put in our best guess for what we think that the true population proportion might be in order to decide what sample size do we want to collect in order to find a sample statistic and actually build our confidence interval. So normally this calculation is done before you actually collect the data. You need to plan how you want to collect the data. You're trying to determine your sample size. Here's how we do it. So let's solve for n. So we'll divide by z star. We'll divide by our critical value. So the next thing we want to do is square both sides. So our margin of error divided by our critical value. If we square that, that gives us p times 1 minus p, all divided by n. So you can cross multiply in this case. So what we have is n then times this squared expression, the margin of error over our critical value. That quantity squared is going to equal p times 1 minus p. So in order to finish our derivation, to solve for our sample size, we just need to divide by this squared quantity. So we have p times 1 minus p, and we will divide that by this squared quantity, the margin of error, over our critical value. That quantity is squared. So in this context, we're trying to determine what sample size do we need in order to set a margin of error of, let's say, 8%. Well, in order to do this, I want to use my best guess for what I believe my population proportion would be. Well, if you don't know, if you don't have a guess, if you will, for what your population proportion might be, your best strategy is to use 0.5. 0.5 will make the numerator as large as possible. And what that will do is force your sample size to be maybe even a little bit larger than it needs to be in order to guarantee the margin of error that you are interested in. We, though, have a better guess than 0.5. We've already seen sample data that suggest and those sample data are our best guess for what the truth might be. When we used a sample size of 30, we got a p-hat of 0.73, so we might as well use that as our best guess for what the truth might be. We've at least observed that. So we have 0.73 times 1 minus 0.73. We would like to set a margin of error of 8%. We'll say our level of confidence is 95% confidence again, so we can use our z-score of 1.96. So at that point, we'll evaluate it on the calculator and see what happens. So we have the 0.73 times 0.27, that's 1 minus 0.73, and we'll divide by our margin of error, 0.08, divided by the 1.96. That quantity we want to square. So what's interesting here is we get a sample size of 118.3. Well, we can't have 0.3 subjects. So even though this 0.3 is less than 0.5, we're going to go ahead and round this up. We need at least 118.3 subjects to get our margin of error of 8%. If we round down to 118, we might not actually achieve that 8%. So in order to establish that margin of error, we almost always round up in this case. So we want at least 119 subjects. So that is the number of subjects that we would want to use in order to set this margin of error at 8%. Certainly quite a few more subjects than 30. Now, something interesting that I would like you to notice, if we go back to the formula, take a look at this. Notice that the sample size is in the denominator. So if I want to cut my margin of error in half, that really is the same thing. Well, here, let me write it out. If I wanted to cut that margin of error in half, I want 1/2 of my z star times the standard deviation. We'll just come back to the formula that we had originally here. So I could have guessed that the final result would be 119, and here's why. The truth is that if I had to choose it, I'd choose 120, and here's why. So that 1/2, I can rearrange this by putting z star in front, and I'll put the 1/2 next to the radical. And I actually want to take this 1/2 and bring it back under the radical. So what you have to think about, what do you have to take the square root of in order to get a 1/2? Well, that would be a 1/4. So if I want to rearrange this, instead of having the 1/2 outside of the radical, that's the same thing as having my p-hat, my 1 minus p-hat, all over 4n. So that 4 is just like a 1/4 under the radical. If the square root of 1/4 would be the 1/2, here it is. Well, notice, to get half of the margin of error, what I need is 4n. I need 4 times the sample size. The original sample size that we used was 30. 30 times 4 is 120. So our calculations gave us a value of 119, and indeed understand there are some things that have been rounded here. For instance, this 1.96 is rounded. So 119, 120, I knew the answer had to be close to 120 in order to achieve the 4 underneath the radical, because that 4 underneath the radical in the denominator is what gives me the 1/2. And our whole goal was to take the margin of error and cut it in half. So in general, going forward, if I'm working with one single population proportion, this is the relationship that we can use in order to establish what sample size will give us a particular margin of error using a particular critical value, a particular z star. The margin of error we get to choose. For p, we want to use our best guess for what we believe the population parameter is, but then we also have to choose the level of confidence, z star. The 1.96 is for 95% confidence, but the truth is you can choose any level of confidence that you like. Hope this has been helpful.